Welcome back to R for Economics. In this video, we're going to be talking about eigenvalues and eigenvectors. So the first thing we're going to do is bring in the stats package, which is the one that has the eigen function in it, and PLYR in order to just organize some data. So let's bring in our common database that you've seen in many of the videos, is the MT cars database. And you can see that it's got a lot of data and a lot of headings. Now we want to subset this so that we exclude some of the binary ones from our list. And now we've got data new, which just has much more, doesn't have the identifier series included. Now the next thing I'm going to do is generate two functions. One will demean the data, so it'll take the mean and subtract it. The other one will standardize it, divide it by the square root. And this is to essentially turn these all the series into things that are centered at 0 and with a unit variance. So we can take our data new and we can make st data dat, which is going to be a standardized data set. Now, when we're doing eigen, we can either use correlations or not, but this is the object that it's going to try to get the eigenvalues of. Now we could do it on data new, but we're going to use the correlation matrix, because what it does first is make a matrix. And we can see what our eigenvectors are, minus 0.393, minus, and so on. So each of these columns indicates an eigen vectors for each of the things. And if we look at the eigenvalues, we look at the square root of those are actually the standard deviations for each of these. Now we can look and see how much the variance is explained by each of these eigen vectors. And we can see that the eigenvectors, the first one explains 62.8%, the next one is 23.1, and then 5.6. And you see that they get smaller and smaller, such that the last one provides very little variation, explains very little of the variation. And we can also see if we wanted to, we could look at these things added up, and they're 9. Now, why is that the case? Because the correlation matrix is going to standardize everything to 1, so the total variance is going to be equal to the number of elements that you have in your series. Now, the next thing we have is that we can create the factors from the eigen vectors. So the eigen vectors provide things to multiply. So this one is multiplied to our first series, which, if we go up, is the MPG. The second one is the cylinders. So this would be multiplied to the cylinders. So we can actually generate a factor, and we can generate factor 1. And we can see that it just generates a series that is the length of the original series, which is 32 observations. And we can do this for our second factor, our second column from our eigenvectors matrix. Now, why would we want to do this? Well, the vectors have particular properties, such that if we take these, take our standardized series, multiply them together, divide by the number of rows, we get exactly our correlation matrix. Now, the other thing we can do is we can take any of our factors and we can find the variance of it. So if we take the variance of this, we can find that it's 5.6559. Square root of that and the square root of the second one, and we notice that the first one is the variance explained by the square root of the variance explained by the first factor is the same as the eigenvalue for the first element. The variance of the second factor is giving me the eigenvalue for the second one, and so on, all the way down. Now, the other property of factors developed from the eigenvectors is that they should be orthogonal. So if I take the first one and transpose it and multiply it to the second one, I get something which is down to machine 0. And this is double precision, so e to the minus 15 is essentially 0 according to the machine code at this point. Great, and we'll see you in the next video.